Welcome to my channel youandcloud.com. This is your host Rahul, and today we will learn some basics about Docker. This demo is for absolute beginners to understand what is Docker and where it fits in the modern infrastructure setup. So let's start. In general words, Docker is a container runtime software developed and owned by Docker Inc., which provides runtime environment for container-based applications to function. We also have Cryo, which is also an alternative container runtime tool available in the market. To get some more clarity, let's go a little back in time when application was developed as an bundled archive. For example, let's talk about a Java-based application are used to be in the extension of jar, var, or EAR, which is also called a monolithic applications. Complete application components were bundled together as a single executable unit, which means if some small component of that application reports a bug, the entire application needs to be redeployed, which is a hassle for development team as well as for the support teams. So these applications we called monolithic applications, which are built on Java. We do require a runtime environment for them to host. For this, we used to have Java-based application servers. For example, we have Tomcat, WebSphere, and WebLogic application server. And we also call them traditional application servers. Let's move forward. So since last few years, IT industry is moving away from the above described model and moving towards the microservices based architecture, where a single application component are divided into multiple independent microservices. So when we say independent, that means all those microservices do not carry any dependencies. They are self-independent. Containers are lightweighted in terms of support. It is easy to scale and fault tolerant. In this scenario, as a single application divided into multiple microservices, deployment of one part of that application won't impact the entire application, which means if you face a bug with a single component or single microservices, which is only a part of that application, you need not to deploy the entire applications once again. You can just simply deploy that specific microservices, or I would say redeploy that specific microservices, and your other components are remain unaffected from that bug or from that uh, deployment, I would say. So this is a simple example of a traditional application server WebLogic, which is used to host monolithic Java-based applications. So let's talk about Docker software. As we already discussed, this is a container runtime platform for microservices. Okay, so the next thing is Docker file. So Docker file is nothing, it's just a text file which has set of instructions on the components you want to include in your Docker image. For example, if you want to deploy a simple Java application as a container, you need to include tomcat into your Docker file, and then you have to place the instructions to deploy that sample application into tomcat within that Docker file and then build it. We will also see a demo for the same in a couple of minutes by now. So the next component is Docker image. So once you build your Docker file, you'll get a Docker image. You can consider it as a file which has the instructions. It's a compiled format, I would say, of that file or that Docker file. And you'll get a Docker image as an output, and that image can be deployed and run on the Docker container runtime software. What is the Docker container then? So Docker container is a runtime instance of the Docker image. So that means we have built a Docker image Okay, and the Docker image has set of instructions which we wrote in our Docker file. So if we wanted to run that Docker file, including all those instructions, we will deploy that Docker image into container runtime, and we will get a running Docker container. So what is Docker repository now? So consider it as a storage repository or storage folder where you store all of your images. So it's a specific store to keep your images. It can be locally, it can be external. So externally, you can also get public versions of Docker repository or image repositories or private set of repositories, which you obviously have to pay and purchase those services. And the entire part of that repository will be private to you. Docker Swarm. Docker Swarm is one more component, and it comes into picture when you need more than one instance of Docker runtime as a cluster. That means you want more than one Docker runtime instance, and you want it to include all those instances into one single cluster to support high availability and failover capability. Let's say you have two data centers and you have installed two different set of Docker runtime into those data centers, include them into a cluster. So that's in case one complete data center goes down, you still have your availability and request being served by the data center B. So this is the whole purpose. Okay, friends, let's move to a demo now. I will try to showcase how to deploy a, a simple Java application. First, we have to write that Docker file, compile that Docker file into a Docker image, and then we have to deploy that Docker image as a Docker container. So let's move forward. I have a running instance of Ubuntu operating system. You can see. Okay. So let's start with a Docker install. For Docker installation, I would use this command. And if you want, all these commands are available in my video description. I would say yes. It is downloading those binaries. The duration depends upon your network bandwidth. Okay, so now we have Docker installed. Let's check if it is running or not. So this will be the command for checking Docker service. Right. So we check about Docker service. Yep, it is very well up and running, and it is also enabled state. That means the next time when you will reboot your machine where this Docker container is running, yes, your Docker service will become running automatically. You need not to manually restart or start that service. Cool. So we have already downloaded this sample.war Java-based application, and we will be using this application in our demo. So I also have created that Docker file. Let me show you the content. So this Docker file has few instructions starting from keyword, which states the tomcat base image, label with my channel name, add. So in this line, we are adding our code file, which is sample.war, to the tomcat directory for deployment within our container. And expose, we are using to expose 8080 port out of this container. And the last is the cmd command. So this is the script for to start the tomcat container runtime. So the cmd is used to start tomcat application server. That is the catalina.sh. and we have to run it. So what we are doing is we are using a tomcat, we are labeling this as in any name, and we are adding our code file and deploying into this directory within the tomcat instance, exposing the port 8080 and starting our tomcat instance. That's it. So let's do it. So we already saved this file as a Docker file. It's a simple text file. So the next step is to build this Docker file as a Docker image. So for that, we have to use a Docker build command. So I'm using simple Docker build. I'm tagging my image with version 1.0. Okay, let's hit that. So you will notice like it will download all the dependencies. Like I do not have that Tomcat image, base OS image locally. So it is downloading from the internet, and then it will include my code, which is also present locally into that image, and create a Docker instance or Docker image to run as a Docker instance. So let's wait to get it completed. So now we can see we do have a successful build, and we do have a image ID. Cool. So, and we also have tagged it with the name youandcloud as we specified in our command. You can notice here. And this dot specifies like it has to look for code or other dependencies locally in the same directory from where I'm running this command. So now as we have Docker image available locally, so let's go ahead and deploy that Docker image as an Docker container. So for that, we will use Docker run command. So in this, what I'm saying is Docker run to run. This is the command to run the Docker instance. -d it's to run in a detached mode. Detached mode means even though if I'll hit the control C, the process will remain running as a background process. It is not running as a foreground process, which we have to run. So this name is the name of the application. I want to give this name to my application. -p specifies ports to be exposed. So this is the port exposed into container to my local machine. And this is the Docker image, which I want to deploy with the tag 1.0. So let's go ahead and hit that button. Cool. So it gives us the container ID. So now let's run the docker ps command again. And this is the name. You can specify any name for your application. So how do we test that application? So for that, let's try to curl that application. So for that, let's curl that application and see if it is responding. So I'm curling it from my local machine, specifying localhost. That means it will only check the processes running locally in this machine, and port would be 8080 as we specifies in our instructions, and our container also running on that specific port. And this is our application. So let's validate. Okay, it says 200. That means our request is a success, and it returns the application output. The page we just tried to hit is a JSP page, and it has this message hello. So that means we have successfully deployed our Java application, which was earlier into format of .var as in Docker container. If you want to download that application sample.war, check the description area of this video. Thank you very much for your time, friends.